What would it be like if we could traverse the entire universe? What wondrous things would we see? Could we ever reach the most distant galaxies? The most distant stars? We could definitely not do this in our lifetime, as galaxies and stars are light years away. However, we can board our spaceship of the imagination and travel to a star that is actually rather close to us. Sol, our sun, might not be the biggest star or the most unique, but it is our star. So hop aboard our spaceship and let's go visit our sun. Since our sun is a normal star, we can compare it to the other stars of the universe. How convenient! Before we see how stars are born, let's take a moment to discuss what stars actually are. Stars are made of gas, dust, and plasma and vary in size from 12 miles across to 864 million miles across. No matter what their size, all stars have essentially the same chemical composition and use thermonuclear fusion to change hydrogen into helium, producing large amounts of light and other energy. Sol is a relatively small star. Some stars are more than 100 times as massive and 100,000 times as bright as our sun. On the other hand, dwarf stars are less than 1/10 as massive as the sun and 10,000 times dimmer. Our sun is an average white star, although it often looks yellow through telescopes because of protective filters. Stars hotter than our sun are blue, while cooler stars emit red light. Star nurseries seem like giant phantoms haunting empty space, shrouded in mystery and dust of the ancients. They look like something one might find in a fantasy world, giving the space around them a surreal quality. Astronomers call these mysterious objects nebula, the Latin word for cloud. And indeed, nebula are cold clouds of gas and dust, so enormous that light travels for years without reaching the end. In these clouds, stars begin their lives. As gravity pulls on the gas and dust in the nebula, the particles draw closer together, forming a clump of matter called a core. As gravity continues to pull the molecules together, the core begins to spin. When these cores become large enough, they condense and collapse on themselves, creating a dense central region. The core is heated by the energy of the gas, and the cloud of dust and gas has become a protostar. At this point in the life cycle, the protostar is surrounded by empty space and a cold cloud of gas and dust. As the protostar's temperature increases, nuclear reactions begin. The spinning protostar accelerates, becoming more compact. The increased spin causes the cold cloud of dust and gas around the protostar to flatten into a disk, which may eventually form planets. As the star continues to spin, gas flows from its poles. The movement created by the gas jets clears the remaining gas and dust from the surrounding area of the protostar. After this, the protostar stops emitting gas from its poles and begins to settle down. The star converts hydrogen gas into helium, creating immense energy and light. Very small stars will continue this helium-induced energy boost for about 100 trillion years. After this time, the star begins to die, shrinking and fading away like the flicker of a dying candle. This is a peaceful way for tiny stars to end their existence, but other stars are much more dramatic when they expire. Our sun, for instance, will expand as it begins to die, becoming a red giant with a radius 100 times greater than normal. And then it will shrink, losing much of its mass in space, until it becomes a white dwarf, surrounded by a nebula. Much of what happens to a star in its lifetime depends on its size. Stars 1.5 to 3 times the size of the Sun begin their lives in the same star nurseries as our Sun, starting as cores of collapsed gas and dust. Just like our Sun, medium-sized stars form a protostar and use fusion to generate energy. However, the medium star goes through its life more quickly, as if eager to live its life to the fullest. When they are about to die, medium stars expand and become red giants. At this point, however, the similarities between these stars and our Sun end. The star will begin to fuse its elements into progressively heavier elements. Hydrogen eventually becomes carbon, oxygen, and after some time, iron. The star continues to fuse elements into iron until it has an iron core larger than Earth. The star has now run out of fuel, causing the core to quickly collapse into a ball a few kilometers across. As the star implodes, pressure from the elements in the star cause it to expand rapidly, resulting in a magnificent explosion called a supernova. Supernovas shine with the brightness of 10 billion suns, and gradually fade with time. Most of the star's matter blasts into space, and may form a new nebula, giving birth to new stars and planets. Where the star once hung in the heavens, only a mass of neutrons remain. These squish together, forming a neutron star. These extremely dense stars are only about 10 miles across. Stars over 3 times more massive than the Sun have an even more dramatic lifestyle. They live fast and hard, shining brightly for their relatively short lives. Large stars are the rarest of all because the few that are born die quickly. Just like other stars, large stars are born in nebula. When their lives begin to end, they become a red giant and experience heavy element fusion. When large stars go supernova, however, they do not form a white dwarf or a neutron star. Instead, the matter is drawn together by gravity into a space so small it occupies virtually no space at all. This is a black hole, a place with such intense gravity even light cannot escape its pull. Black holes have the same gravitational strength as the original star, but are compressed. If our Sun could somehow become a black hole, the planets would continue in their normal orbits because the gravity would remain the same. Although astronomers can calculate the existence of black holes by observing orbits and detecting with radio and X-ray telescopes, it is only with the spaceship of the imagination that we can see a black hole. What happens to the matter inside a black hole? No one knows for sure. Some believe it is crushed to nothing, while others believe it is transported to an alternate universe. With current technology, we have no way to know for sure. Black holes and other mysteries remind us that there are still puzzles in our universe to solve. And so, our journey through the lives of stars comes to an end. Thank you for joining me on this expedition across our universe.